Okay guys, let's go through this dot and cross today. So we have carbon monoxide. So let's just put down the two atoms, C and O side by side. And then we'll put in the number of valence electrons. So for carbon, right, it has 4 valence electron. For oxygen, it's group 16, so it has 6 valence electron. Okay, so we'll put down for carbon 4 of it. 1, 2, 3, 4. And then for oxygen, you also want to put down like 6, but because it's dot and cross, right? So we'll alternate between dot and cross. So we'll just put down like 6 electrons. 1, 2, 3, 4, 5, 6. Okay, so we realized that for oxygen, right, it has reached octet configuration, so it's very happy. But for carbon, did not. So if you count all the valence electrons around carbon, there's only 6, including the shared electrons. So what can we do about it? We can actually shift a pair of electrons from oxygen over to carbon. All right, so instead of forming a normal covalent bond, which one electron is taken from each atom, we will take instead both electrons from oxygen and put it to a dative bond. All right, so I'll make the correction in red so you can see. So we'll take away these two. All right, and then we'll put in this way. All right, so both the crosses represents electron from oxygen that are used to form a covalent bond between carbon and oxygen. So end of the day, right, we get a compound that has like triple bond. All right, so each of the carbon and oxygen, they now both reach octet structure, octet configuration. So this is how we draw the dot and cross for carbon monoxide.